Hello guys, welcome to this Dart session. So for today, it's going to be all about OOP. That's what we're going to learn today. So I'm going to create a file here where I'll be writing my notes, a text file. So I'll just call it notes.txt. So I'm going to try to make this session as practical as possible. So one of the areas that most of the developers really don't understand is OOP. And you realize that if you understand the OOP for any language, then it will change how you write your code. It will change how you view your code. You'll really have a better understanding of how to write clean, maintainable code. So we are going to make it a very practical session so that we get an understanding of OOP. So OOP just stands for object-oriented programming. So I'll just explain it in a very simple way in how I understand it. So programming languages will give you data types. It will give you a way of writing functions and very many predefined things. But when you want to create a real world scenario, a real world object, you realize that the predefined data types that are given by predefined data types and classes that are given by the language are not enough. So you need to use certain mechanisms to create real world objects. So that is just like the meaning of object oriented programming. So we take real world objects by using certain things that are provided by programming languages to create them. So in object-oriented programming, we'll be talking about classes. We'll also be talking about objects. Then we'll be talking about things like inheritance. We'll also be talking about encapsulation. After encapsulation, we'll also talk about polymorphism. Then finally, we'll talk about abstraction. So these are like the main elements of OOP. If you understand these six, then you are basically good to go. You can write your OOP code without any problem. So that is what we are going to do today. So let's just get into it. So I'll not be going into like the real definition of a class of object. I'll just give you the raw understanding of how I understand it. So because programming is always about understanding things, it's not about memorizing definitions. So I'll just give it to you uh, like the in a raw manner as it is. So let's just get into it. So I'll try to maybe think this font is just okay. Increase my font just in case it is not very visible. So in case you want to increase your font, you can just go to settings and then instead of 20, let's try 30 and see how 30 works. We can work with with 30. Yeah, maybe we can work with 30. So the first thing that we're going to talk about is classes and objects. So the concept of a class is if you want to create a program that executes things that are kind of related to each other, so you try to use a class, but I'll still give you the definition of a class because it's important that we define them. But how I understand it is if you want to write code that is kind of takes everything that you have and bundles it in together. So that is when you use a class. But just to define what a class is a class is like the blueprint of creating an object, if you want to know the definition. So a class is the blueprint of creating object. So a class is the blueprint of creating an object. So let's take this scenario. You have a recipe for creating a certain dish. So let's say the recipe is for creating a cake. So in this case, the class will be like the recipe. Then the object will be the cake itself. Now, so the object is like an instance of class. So that is like the object, an instance of a class. So the object in this case is the cake. So maybe you can take it using that analogy. Classes are like the blueprint of creating an object. So in this case, you have a recipe for creating a certain dish. Then now the real dish that you are creating is the object. So an object is an instance of a class, but in this case, we're using a cake. So take an example of a recipe and a cake so that you understand the concept of classes and objects. Okay, but now how you write that in code is that there is a certain syntax that you follow. So you use the keyword class and then you have the class name. So for example, let's say we want to have a class person. So we have a class person and then you just enclose it like that. So that one gives you, that is a simple syntax for having a class. So you need to know that a class has certain fields in it. So one field that we can have in a class is what we call class properties. So we have class properties. We have class properties and we have like different properties we can have. Let me just start with. We have like instance properties, and we also have like static properties. So let's just talk about properties in general or attributes. So when you have like a class that mirrors a person, so you know a person normally has certain characteristics. So those are what we call properties or attributes. What properties or characteristics does your class have? So for a person we can have like a person can have a name. Then a person can also have age. But you see in that, if you declare a variable and you don't initialize it with a value, then you have to say that it can be null. So we add that there. So now these are what we call class properties or class attributes. So I hope that is okay. Then we also have methods. So we also have methods for a class. So these are what we call properties, attributes. So a method is just a function within a class. So instead of calling it a function directly, we try to differentiate it by just saying it is a method, so a function within a class. So that is what a method is. So inside this function, we can just have a simple method. So maybe we say void, and maybe we can just say this, we can call it display person. Then inside it, we can maybe print. Maybe we can say just print name. Then we interpolate name. And then maybe in a new line. So that one indicates a new line. So age. Then again, we interpolate age like that. So in this case, we would have created a class. Now this is a class. So this is like our recipe of creating a person. So this is our recipe of creating a person. But we don't, so this is like our recipe for creating a cake now. Or for, in this case, a person. But we don't have the object yet. So this is just our blueprint for creating the object, but we don't have the object yet. So to create the object, you need to create it inside the main function. So you define your class, you define your class separately. Then now you go to your main function, then you create your object. So our main function is just void main. Then here now is where we create our object. So we said an object is an instance of a class. An instance of a class, because here we have a class, but now we want to use that class to create an object. So how we do it? So you see you have this class name here, person. So let me show you the syntax first, then I'll try and explain it. So you see here we have person, which looks like the class name. Then we also have this person here, which is unique. Then we have this one here with brackets. So this person here is the type. It is the type because, in that we talk about types. We have strings, we have integers, but now here it is of the type person, which mirrors our class because what we are creating is coming from our class. So it is of the type person. Then this person here is just like the variable name. You just make sure that it is not the same as the class name. That's why we are using lowercase p. And then person here is now, we are calling the constructor. So you see in this case, when you are creating a class, that gives you a default constructor. So by calling this, we are not calling the class name, we are calling the default constructor because it is the constructor that is used to initialize the class properties and also the the class methods. So I hope that is okay. So this is for the default This one is calling the default constructor. I'll talk more about that, but that is basically the syntax of creating a method. So in this case, we have defined our method. If you're not sure about this, you can always use var here. You can always use the var keyword, but for now, let's stick with that. So after that, now you need, because we had like two attributes up here. We had a string, we had an age. So what this method does is that it gives you access to these attributes or properties that you defined at your class level. So now when you do this, when you say person dot, now you are trying to access everything that is within the class. Now you see you have access to age, you have access to name, you have access to displace person. So you can say person.name is equal to, so in this case, let's use David. So now we are giving the values here. So we say person.name because person is an object of the class person. So now we have access to everything within that class. We also have person.age is equal to, and you see, if you give it as a string, it will be an error because we had said age is an integer. So you need to provide it as an integer like this. So let's do 22. So now that one is like assigning the values of a variable. So the next thing that you do, you just say person dot. So we'll be calling this method now, because if you look at this method here, it prints the name and it prints the age. So if now I run this code, let's run it and see what it gives. Let's run it real quick and see what it gives. So that main.that. See, now it gives name, David, age 22. So just that's how classes and objects work. So just what you need to know, a class is like a blueprint of creating an object. In this case, we've used an analogy of a recipe for creating a certain dish. Then the object is now the instance of that class. So in our case, now the object is like the cake. So it is the dish that you are creating. But now you have to master the syntax of how we create it. So before we move on, I want to also show you, because I said that we have instance attributes, we have static attributes, and also we have class methods and static methods. So for now, we have talked, these are called instance attributes. They can be, so let me come here and do a little bit on attributes. So we have instance attributes. Let's call them properties. Then we have static. Let's also call them properties. Then we also have static properties and methods. So the example that we have here, these ones are called instance attributes. What that means is that when the default constructor is called, they are instantiated inside the default constructor. So these ones are instance attributes. So for now, you don't see the default constructor because I've not talked about it, but it is the next thing that I'm going to talk about. So these ones are called instance attributes. The next thing that we need to talk about is what we call static properties. So static properties are it is, so what a static property is like it is defined within, it is defined at class level, but its importance is that it is available across all class instances. Okay. So it is available across all the instance of the class. So that's why it's called a static property. So how you define it is that you use a static keyword. You use a static keyword. So you just say static. So maybe we want to say something for a person that is accessible, uh, that we want to make to be accessible throughout all the instance of the class. So maybe we can talk of maybe height, because yeah, let's say static double height. So let's make height to be a static property. Sorry. So this one is different from this. So let me call this one. So just for documentation, let me call this one static, and then here we can call this one instance properties. So how you access a static property is that you have to use the you have to access it by the class name. So let me add here, uh, add height. And say height like that. So how we access a static property is that you have to use, unlike the the instance attributes, you can access them using the method. But for static properties, you should be accessing them using the class name. You can still use the, so you see person dot height. So it is accessible across all instances of the class, and that's why we can access it using the class name. So let's say maybe height is maybe 5'9". So a double, so let's just do that because it is a double. So now when you call display person, it will also include the static property. So that means that. So see now, name, David, age 22, height 5.9. So just know that a static property is accessible through all instances of the class, but for instance variable, they must be initialized within a constructor and they are only accessible within the class. So that is the difference. Then we can also have static methods. So what you do is that you just use the keyword to define it. So let's say static method. So I can just say static void, maybe let's just call it display just for the sake. Then we print, just say this is a static method. So also you will just call it using the class name. So here we just say person, because that is a class name, person dot display. So run that. Now we have this is a static method. Then the now the other method, the instance method, is now called. So what you need to know about classes and objects is just the definition, or you kind of have to understand what a class is, which is like the blueprint of creating the object. Then we also need how to you also need to know how to create that particular object. Then the next thing, you should try to understand what instance properties are, and also your instance properties and objects. Then also you need to understand what static properties and instance properties and methods. Then also you need to understand what static properties and static methods are, and why we use static properties and static methods. So try to understand that. So when you understand that, you'll be okay. So that is it about uh, class and object. So the next thing that I'm going to talk about is constructors. So the code is not going to change much, but so that I don't confuse you guys, I'm just going to start over using the same class. So let's say we have a class person plus person, then we have a string name, then we have an integer age. So the next thing that we talk about is constructors. Constructors. Let's do constructors. So constructors are special methods that are used to initialize class properties. So special methods used to initialize class properties. So the beauty of understanding OOP is that these concepts remain the same across all languages, whether it's Python, whether it's C Sharp, whether it's Java, the concepts will remain the same. The only thing that might change is the syntax and the implementation, and very few key features that maybe a certain language has and the other doesn't have. But a class will remain a class, whether in which language. An object will remain an object. A constructor will be a constructor, although they might use different keywords. So if you understand how the general object-oriented programming works, so you can work with you can just write any OOP code in different languages as long as you know the syntax. So a constructor is a special method used to initialize class properties. So here we have a class person, and then we have these properties. So we need to initialize these properties so that they are known by our object, or so that we can assign them values within our object. So that is what a constructor is. But before I define this, I talked about a default constructor at first when we created our objects. And you see, when we were in our main function, when we said void main, like this, then I said person when I was creating the object. Then I did this. We said that here we were calling, we were calling a default constructor here. So we're calling a default constructor. So the default constructor is provided by that. So you don't see it, but it is what helps you. It gives you the ability to initialize your values, because you see when we had like a string, we had like a string name, and we had like an integer age like this. So it gave you the ability to initialize these values such that when you create an object, you can access them. So it is the constructor that gives you the ability to access those values within your class. So when you said person dot, so you see now you had the ability to to give it the name David. So it was because of the default constructor. So the default constructor, uh, just a constructor in general, is a special method that initializes these class properties so that when you create an object, you can have the ability to assign them certain values. So that is what a constructor. Also, you need to know that every time you create an object, so we can say that a constructor is called every time you create an object. So every time you create an object, a constructor will be called. So we are not just saying that. You see, when this is how you create an object. So, but by creating an object, you call the constructor. So every time you create an object, the constructor is called. So that is what it means. But I'm going to show you in an example. So let's do away with this. Then I just show you how we create a constructor. So the syntax of creating a constructor is you just use the class name, person. Then now inside the constructor, I want to have an empty constructor. I just want to have an empty constructor that doesn't really initialize anything. So inside it, let's say print this is a default constructor. So we say that every time you create a method, because this one is every time you create an object, now this one is an object, the constructor is called. So if I run this one, you see there's nowhere I'm printing this constructor, but it is going to be called because we've created the object. Okay, so let's run this. So you see now we have this one printed in our console. It says this is a default constructor. So let me now explain. We have a class person. So our class could have had different properties like name, age. In fact, it could have had a name, age, and such details like that. So we say the constructor it initializes the class properties so that when you are now creating the object, you can assign them values. So we say person, which is of the class type, then this is the object. Then now here is where we call the constructor. So it means that when we create a second object, we will be calling the constructor again. So let's say the second object is person one. So now we have two objects. At first, we called the constructor, and that's why this here what was executed. So now we expect, now we should be expecting two texts here, two print statements, because we have created two objects. So the constructors has been called twice. So now you see, this is a default constructor, this is a default constructor. So I hope you have understood the concept of constructors. So the next thing, we say that the constructor is used to initialize class attributes or class properties. So that is its main function. The reason why we have it is because we use it to initialize class properties. So at first, we didn't initialize them inside the constructor because we only had string. We had like string name, and then we had like integer age. So they were not initialized. And that's why when we were now assigning them values, we said person dot name is equals to David. So this was because we didn't initialize our class properties. So you should initialize them inside the constructor so that when you call the constructor, you just pass them directly. So now we are going to do away with this dot method so that we can just pass them directly. So how we do that? First, you remove this because now we are going to it's like we are asserting that now it is going to be present. So I'm going to show you the long method so that you can understand it first. Then now I I show you the short version. So let's first initialize our name. So we say string name. So then inside the body, now we are going to do something with it. So inside the body, we use this keyword to initialize a class property. So we say this dot name is equal to name. So let's see, where is the error coming from? The nullable instance field name must be initialized. So I think I know where it is coming from. Let me just rewrite that. So let's say person, the constructor, then like this. So string name, then we say is dot name is equal to name. So that one should work. I don't know whether, just a minute. Let me assume that I just define it from scratch. So string name like that. Then we have the constructor person like this. Then here we have passing string name as a parameter. Then we say this dot name is equals to name. So that is what I'm doing. I don't know. So this should be the structure of having a constructor. So I don't know why it's okay. So that takes the error away. Okay. So let's work with that for now. So we have a class property here. And then this is like the long method of initializing a, a class property within a constructor. So we had two of them. We had the other one. We said like integer age. So we had integer age. So for now, we have only initialized the name. So initializing means that we want it to be passed directly inside the constructor. So you see now here, the constructor is complaining because we haven't passed one value. So here, I'll just pass the name. Let me say David. Then here, maybe I'll pass the age, like this. So here we have initialized one variable, I mean one property inside our constructor. So now we can pass it directly. But there is one that we have not initialized inside the constructor. So it means that we have to manually give it a value here. So we say person dot age is equal to 22 because we can't give it we can't assign it here because it is not one of the parameters inside our constructor. So let's do 24. So I hope now you get how that works. So let me have a simple method here. So let's say void display person, then print. Let's just print the name, the age, just like that. So when you run this, so we have to call that method. So we first call it in the first object. So person dot display person. Then we can copy this and then change the object's name. So person1 dot display that. So let's run that. So when you run that, now you see we have object one, we have name David, age 22, name Dalton, age 24. So I'm just trying to show you how it works when you initialize a property inside a constructor and when you don't initialize a property inside a constructor. So let's initialize all of them. So let's now have another parameter, integer, age, and then now we initialize it inside the body. We say this dot age is equal to age, like that. So that means that inside here, we now need to pass the age directly. So we just say 22. So we can do away with this. Then also here, you can now pass the age directly. So we say 24. Then we do away with this one now. So when you run, it should give the same result. You see, it gives the same result. So there's something that I saw in Python. Let me try and change this variable and see how it works and see what it says. The setter names isn't defined for the type person. Okay, so that one doesn't work here in that. So just make sure that it matches everything like that. So just to recap, so the constructor is used to initialize this class properties. So at first, when we didn't initialize them was because we had a default constructor that was doing the initialization in the background. But now that we have it here, we need to initialize it on our own. Okay, so that we can pass these values here directly. So I hope that is okay. So this is the long way of like writing it. So we can have a simple way of writing everything. So let me do this. Let me just remove this constructor here. So the how you can write it in a very simple way is you just say the person, which is the class name, then you just say this dot name, then you say this dot age. So now that saves you a lot of code and time. So this is a short way of uh, writing our constructor. Instead of having the constructor, then you say string name, string age, then you assign them values here. So this is the shorthand syntax for creating our constructor. So just say person, this dot name, this dot age, and the code will still work the same. So the code still works the same. You see the output is still the same. So I hope that is okay. So having said that, I want to talk about these parameters that we have here. So you can have different parameters in your code. So now let me go to my notes here. So now that we've talked about that, we can have like constructor parameters. So constructor parameters here, you can have positional parameters. you can have, let me copy this one so that I save time. You can have positional parameters there. You can also have what we call optional parameters. You can have optional parameters. You can also have named parameters. So you can have named and required parameters. So these parameters are normally important because depending on what you do with them. So the ones that we have here are called positional parameters. So when you are passing your parameters, first of all, you must give those parameters and then they must follow that order. So let's say if I do this, if I take that name, then I start with age, then I do this. So that one will be wrong because we've not followed the order. And also we can't leave out age. So you see that will be wrong. So these are called positional parameters when passing them inside your your constructor. So the next one is optional parameters. So you can decide to make one of the parameters optional, and how you do that is use this bracket here like this. But when you make a parameter optional, you need to give a default value. So when that argument is not provided, which value does it default to? So for example, because we've made, this means that age is optional. So if it is not provided, then take a default value of 0. So now we can leave out age here and you see there is no error. So if you run that, you'll see that age for David, age is 0, and then for Dalton, age is 24. So you see the default age here is 0. So, but if now you give the age to maybe back to 22, the default value will be overridden. So it won't be 0 anymore. It is going to be 22. So you see now the default value is overridden. So that is okay. The next thing is named parameters. So let's go back to what we had like this. So how you make parameters named is you put them inside curly braces. So you just do this. So just do this and then you pass your parameters in. Let me see. So these are what we call named parameters. So I don't know why we are getting that error there. But for named parameters, you need to name them before you pass your values. So that is why they are called named parameters. You need to name them before you pass your values. So somebody might ask, but why do we need to like name our parameters? Why can't we just pass them? Sometimes you have like 10 parameters that you are passing. So you see that one might be a little bit confusing. So you need to like say this one is name, this one is age, this one is phone number, this one is maybe height, this one is so that is like the named parameters. So let me see why we are having this error here. So let me just write that up. So then we have this dot name. Let me see if we have a quick fix for that. Uh, So for named parameters, you can also have like default values when you are giving named parameters, because you see, we have like, if a name is not given, named parameters can be optional. Actually, that's why there was an error. Okay, now I get it. Named parameters can be optional. So, which means that you need to provide a default value for named parameters. Okay, I wasn't getting that part clearly, but now I get it. So you see, named parameters can be optional. I can leave out this one and there won't be any error. You see, there is no error. But because I've provided default values like this dot name is equals to person, this dot age is equals to that. So that's why there was an error. So if I run this now, for named parameters, they can be optional. They are by default optional. So now if you run that, you see age is 0, name is name person, age 0, because you've not provided any value. But if we if now we provide the arguments, then the default value will be overridden. So now we have name David, age 22. So these are called named constructors. So note that. And also the reason why we are naming them is because sometimes we have a list of many parameters. So you have to track this one is for this. Then the beauty of also named parameters is that you can give them in any order. So the order doesn't really matter. So even if you come here and then just paste the name here, so it doesn't matter because you have named them, so there is no problem with that. So the next one is what we call required parameters. So required parameters, you like you're it's like you are enforcing that you must provide this. So how you make them required is you just add the required keyword. So here you just add required like that. So see, you can have like different parameters in your constructor. You can have a required parameter, then you can have a named parameter with a default value. So here, this means that you can't leave out name. You can't leave out name in any way. See, if I do that, there's an error. So you need to have name. So you just have David. So required parameters are so they are named required parameters because you must name them. So they are inside this curly braces. So that does it for parameters. So for now, we've talked about classes, we've talked about objects, we've talked about instance properties and methods, static properties and methods, constructors. We've talked about a default constructor, and then now we've talked about parameterized constructors. So the ones that we were talking about here are what we call parameterized constructors. We have other types of constructors, named constructors, etc. But we won't go into that for now. So we've talked about positional parameters, optional and named parameters. So the next thing that we are going to talk about is what we call encapsulation. So the next thing should be encapsulation. So I think I should have the encapsulation here first. So, so what is encapsulation? So sometimes when you are writing your code, so there are certain values that you don't want to be accessible in other parts of your code. So encapsulation is just restricting, you could say it is maybe restricting access of certain properties within your code. Yeah, I think that's how I can define encapsulation, but let me see. Yeah, so it is just, hiding data within a library. So that is what encapsulation is. So sometimes you are writing code, but there are some parts of your code that you don't want to be accessible, uh, like throughout all instances of your class. So that is what encapsulation is. So let's say void, not void. So let's say maybe we have a class. So let's try and use a different example. So maybe we can have bank account. Let's say we have a class bank account. Then we have properties like maybe we have double balance. So let's say we have double balance. Then yeah, let's have double balance. So then we have our constructor now, bank account. Then we just say this dot balance. So in this case, balance is it is not balance is just a simple class property. But if you want to make it not to be accessible within other fields, we need to make it private. So how we make it private is we use this symbol here, underscore. So underscore is making a certain property to be private. So that's just how it is. So maybe we can have a method here, a method that maybe calculates a method that accepts deposit. Yeah, let's do a method that accepts deposit and that allows a user to deposit money. So maybe we can say void deposit. Then for you to deposit, it means that you need to give an amount. So let's say integer. So we take a parameter of amount. Then in here, so there is something that you need to check first. So you say if, because you are, when you are giving an amount, when you are making a deposit, the amount that you deposit should be greater than 0. So we say if amount is greater than 0, if amount is greater than 0, then now you can make your deposit. So what we are doing here is that we are increasing our balance now. So we're just going to say balance is equal, you add and then you assign. You add and then you assign. So that is what it means there. So you add and then you assign. So then you just print balance. Balance there. Like that. Else. So if the amount is not greater than 0, then you just say deposit should be greater than 0. So let's focus on this method first before we even make everything private, so that we'll explain about encapsulation as we proceed. So let's just make this one here like this. Then we can also have a method for withdrawing. So let's say void withdraw. So this one is for making a withdrawal. So also when you are withdrawing, you need to have an amount that you withdraw. So inside the body, you need to check if, so the amount that you are withdrawing should always be less than the balance. So if balance is greater or equal to amount. So if they are equal, so it means that you can withdraw everything in your account. So if balance is greater or equal to amount, then you need to now subtract the balance. So you say you subtract, then you assign. So what we are doing here, this one is the same as saying balance is equals to balance minus. That is what we are saying there. Then we just print. You have drawn amount. Drawn amount. Balance is balance. Balance is balance. So now we just have our class property here. We have initialized it inside our constructor. Then we have two methods for making a deposit and making a withdrawal. So inside our main, we need to create a method. We need to create an object. So we just say bank account, then we can call our object account, then we call our constructor now. Then now we pass the balance. So let's say the initial balance is maybe 500. So the initial balance is 500. So the first thing that we need to do, we need to account dot. So we need to deposit. So when you are depositing, maybe I want to pass an amount of 500. So after depositing, so after depositing, this is what we'll get. We'll say, so after depositing, when we call this method, we'll get this text here. So because you have say, let's add something. You have deposited amount. Then we say your just have balance. So that is what we get after a successful deposit. So then we also want to withdraw. So we just say account dot withdraw. So when we withdraw, so you see now our account has 1,000. So we can withdraw 800. So when we withdraw, you say you have withdrawn an amount, balance is that. So, but if the value that you want to withdraw is bigger than your balance, then you say you have insufficient amount. That is just the problem that we have had. So I've decided to use this example so that after this now I can explain encapsulation. So because this is now like a real world example of like OOP. So just to recap everything, we have a class property called balance. Then we've initialized it inside a constructor. So we have a method for depositing. So it takes a parameter amount. So we say if amount is greater than zero, because you can't deposit a negative value. So if amount is greater than zero, then you have to increase the balance by saying balance, you add and then you assign. So you add what's on the right and then assign it to this one. Then you print that. So then also you withdraw, but when you are withdrawing, it's either your balance is greater or equal to the amount that you want to withdraw. Then you do that, then you do that. So let's run this and see what we get. So when you run that, you see you have deposited 500, balance is 1000. Then you have withdrawn 800, balance is 200. So assuming we want to withdraw 1000 now. So if we run that, balance should be zero. See, balance is now zero. So if you change this expression to be just greater than, it means that a person can never withdraw all the money in their account, because you are saying balance must be greater than amount. So if you want to withdraw 1000, it means that it is going to be wrong. So, and that I think that is not a very good code. So if we say that main that, see, now it says you have insufficient amount in your account, but you actually have enough money. So this one should be greater or equal to. So let's try and withdraw 10,000, which is not in our account now. So we do that, we get you have insufficient amount. Then maybe let's try to withdraw negative value now. Let's see what it says. So now you have balances that. So I think that was like an error. I needed to have checked that, because you can't withdraw a negative value. You see, you can't withdraw a negative value. So we need to check two conditions here. You need to check that the balance is greater than amount and the amount is also greater than zero. So, and how you add that, you say and amount is greater than zero, and that's how you test your code for errors. So see, now here amount must be greater than zero, the amount that you are withdrawing, so that we don't get such errors. So now let's try to withdraw negative 10,000. So it says you have insufficient amount in your account. So that code works. So the next thing that we want to do, we want to talk about encapsulation. So we said that encapsulation is just hiding data so that it is not accessible outside the class. But there's something that I need to. Okay, so how you achieve encapsulation is you use underscore. So by using underscore, you are making a variable to be private. So this one is making the variable to be private. Okay. So let's use it like this. So that is what we call encapsulation, because you don't want your certain properties to be accessed outside of the class. So now my balance is private. I've decided to make my balance to be private now, like this. So now all my balance there is private. So there's something that you should understand about private variables in that. So if I say a property is private, you can still access it outside the class, but you cannot access it outside the library. So a library is like a file. So you see this variable here, can be accessible inside and outside this file, even outside the class here. But outside this file, maybe if I had another file and then I try to call this uh, this private property here, I won't access it. So in other languages, uh, encapsulation is in terms of class level, but in that it is only done in library level. But good practice is if you have a private property, then you should not access it outside the class. What you should use is what we call getter and setter methods. So we are going to talk about getter and setter methods. So a getter methods, it gives you access to your private property, private class property. So that is what a getter methods, because the reason why we are making this to be private is we don't want it to be accessed outside this class. But in case of that, so we don't want it to be accessed outside this library. So we need to have a method that can return it back. So there are two ways how you can write that method, but there's the good way and the bad way. So the bad way is that you can have a method, just the normal method, and then you say get balance like this, and then you return balance. But this is not good practice because so it needs to be a double return type. But this is not good practice because just for you don't need to write a big function like this just to return a property. So we have in that we have two properties. We have a property called get. We have a property called get. So here we'll use the get property. We have a property called get. So how you do it is you just define the type of what you want to get. So double, then you say get. Then now you give the name of what you want to get. So let's call it balance. Then it doesn't have this, so you just do this. Then you return balance now. So that one gives you access to your your private property so that you can access it outside the class. So when you come here, so now you can do account dot. So you see now you have account dot balance here. So so now you can print and see your balance. So let's print this one here now and see our balance. 100. You see now it gives us back our balance. So balance is 900. So that is a getter method. So if you are in another file or another library, you you would not be able to access the private property balance independently. So that is a getter method, and we use the getter property. So the next thing is if you want to reassign the value of the balance. So you use a setter method. So you want to set the value of the balance. So you can use a setter method and we use the set property. So we use the set property. And always we have the bad way and the good way of doing it. So the bad way of doing it is that you have the return type of double and then you say set balance and then it takes a parameter. So let's say now because you want to give a new balance, so balance Then now you you reassign the balance to the new balance. So you kind of just say balance is equals to new balance. Then you return new balance. But you see, this one is like an overkill. All you need is just a very, a very simple function that can do, that can solve your problems without like having to do a very uh, complex method like this. So what you do is you just have a, so also this you can have a shorthand syntax because it's good that you write clean code. So how you do that, you can just use the shorthand syntax like this. Then so instead of returning, just have that. So just a one liner like that. So you can change it into one line, just like that. So for our setter, you just have your set keyword there. Then we give it a name balance. Then you pass in your new property, the property that you want to give out. So let's say it is double. You can call it new balance like that. So you can either use shorthand syntax or yeah, so let's just use shorthand syntax. Then we say balance equals to new balance. So this is how you set it. Let's see if we can set to a new value. So you come down here. Then now we are trying to set the balance. So we say count dot balance is equal to. So let's set the balance now to 1000. And let's print this one now. See if the balance changes. Print this. You see the initial balance was 900, but now it's 1000. So encapsulation is not a really in encapsulation you only talk about you only talk about a few things. So the first thing that you talk about in encapsulation is like private and public. So you need to know the difference between a private attribute and a public attribute. Then the next thing that you talk about is getters, getters and setters. So actually that's all for encapsulation. If you try to understand that, so how you make a property private, you use the underscore. Then you try to understand how you can have a getter and how you can have a setter method. So these methods will be used to access this property outside this file, not just because within the class. And also you need to know like the scope of how you can access a variable, I mean a property, whether it's within the class or outside the class or outside the file. For for that, uh, private properties cannot be accessed outside that library or that file. So that's where we used that's where we use getters and setters. So I think that's okay for now. So that is it for encapsulation. Let me see if I'm still recording so that I don't end up. Okay, we are still on. So we have three more concepts to go. So let's do inheritance. So just like the name, inheritance. So let's take an example of like you, the person watching this video right now. You probably look like your dad, or maybe you look like your mom. You have inherited certain features from either your dad or your mom. So maybe if your dad had beards and you are a guy, so you probably have beards. Maybe you have inherited how he speaks, or how uh, like there are just certain things that you inherit genetically from your parent. So that is the concept of inheritance in the example that I've used is the same, that it is the same way that we use it here in coding. So in inheritance, we have a parent. Or we have a parent, yes. We have a parent, and then we have a child. So a child inherits from a parent. Okay. So a child inherits from a parent. So in that, a parent class is what we call a superclass. Then a child class is what we call a subclass. So in this case, your dad is your parent, and then the child is you. So there are certain properties that you guys share. So that should just explain it. So in code, now, let's say we have a class. So, mhm. So now we can have a class person. Let's go back to what we had at first. So we can have a class person. So a class person in this case, we want it to be our parent class, because so my upward key arrow is not working. So let's say this one is our parent class. So class person. So a person can have a name. So let's do string name. A person can have a name. So at first, we are not going to use constructors so that we get the concept of inheritance really well. So we have a person. A person can have a name. Then a person can also have age. So person can also have age. Okay. So then a person can have maybe a method display person. So we just want to display the details of this person. So we just print the name. This is what we call string encapsulation. I mean string interpolation. Then I want to print my result in a new line. Then age, which is just that value there. So you see now we have a class person. So that's like our parent class. Then let's have our child class. So it is child slash sub class. And then here it is parent slash super class. So we want to have a class of students. So we say class student, because a student is also a person. So class student, we want the class student to inherit from a person, because a person can also be a student. So we want the student to inherit, the student to inherit from a person. So in that, instead of saying inherits, we use the keyword extends. So extends means to inherit. So class student inherits from the class person. So that is what we are doing there. So then a student will have their property. A student can have like a school. So student can have a school. Student can have a school there, like that. Then a student can also have now a method. So void display student, like this. Then now because our student inherits from a person, so it means that it has access to everything that a person has. So now we can have a name because this student is inheriting from a person. You see here, we are only defining a school, but now because it is inheriting from the class person, now we have access to name and age, and that's why now we can print them out here so that you can see them. And then because then now we provide the school here, the property for the students now, like that. So we have our super or parent class, which has these properties: string, age, and string, and integer, string name and integer age, and then we have this method here. Then we have a student class which inherits from a person class. So by inheriting, it means that it is taking all these properties and methods that this class here had, and then now we have access to them here. And that's why now we have name, although name is not defined here and there is no errors. And then we have age, and also we have school. So in now creating the object, so which object do you think we should create? Should it be a person object or a student object? So we should create a student object because for the student object, it will have access to the person class and the student class. If you create an object of the person class, it will only have access to the person class only. But if you create an object of the student class, it means that it will have an access to the student class and also the person class because it is extending that. So the object that we'll create is of type student, then maybe we'll call it student is equals to students is equals to student, like that. So now we've created an object, and because we don't have constructors yet, so we can just give them values. So student dot name, so we just say maybe the student is David, then student dot age, so just do that, then student dot school, just do that. So the next thing that you do, now you can call this method. So student dot display student, because this one has access to all the other methods. So let's run that. So now we see we have name, age, and school. So that is the concept of inheritance. You have a super class or a parent class, and then you have a child class which will inherit these properties and this method here so that it can have access to it here. So when we come, we only create one method. We only create the method student. We only create the object student, and then you give it the values. So when you call the method display student, so it can give you access to all these values that we have up here. So that is when we are not using constructors. So we also need to talk about inheritance of constructors. But before we talk about inheritance of constructors, we need to talk about the super keyword in that so that you understand the inheritance of constructors. So super keyword. So let's talk about the super keyword in that. So I'm going to clear all this and just have a very simple class with like yes. So what I'm going to do, just going to have a simple class so that I don't complicate things. So we have a class person, and then I just want this class person to have a simple method. So let's say void, let's call it show. So show, inside the show, we can just print this is class, I mean a parent, a person method. So let's have that there. Then in here, inside this class, I also want to have the same method with the same name, although we are not going to. Yeah, so let's say mm, let's just call it show also. So void show. So you see, because here we are in different classes, we although we have the same name, the scope is different because we're in different classes. But there is what we call super. The super keyword is used to refer to the super keyword is used to refer to the parent class. So if I want to call a method from the parent class, so like for example, this show method. So the reason why I've used uh, the same name here is because I want to demonstrate how we can have like the super method. So I want to say super dot show. So inside this method, I'm calling a method in the parent class. So you see now I have super dot show. And then now inside this, I can print this is a child class. Let's say child method. So when we create our object, we say student dot. So we have student dot show. So which method are we calling in this case? The method that we are calling is this, but inside that method, we have another method from the main, from the parent class. So let me just start over. We have a class person with a method show. So inside that method, we have a body that is executed. Then in our child class, we have a method also by the name show. So actually you shouldn't be worried about the method name because they are in different classes, so we can have the same names. Then now because we want to refer to the method in the parent class, so we need to use the super keyword. So we are calling it. Then for the body of our method here, we just have this. So what output do you expect? So I expect this one to be printed first, then followed by this because we are calling this super method here. So the reason why I'm introducing that super super concept is because we are going to use it in inheritance of constructors. So you see now we have, this is a person method. So the first one was called is this, which is this method, because it is from the parent class. So that is just what I wanted to show you. Then this is a child method. You see, this is what it prints next. So now, having clarified that, we want to now talk about inheritance of constructors. So let's do away with these functions here. Do away with this function. So we can go back to having a string name, then integer age. Then we can have a constructor person. Then we can have this dot name, this dot age. So then inside our class, inside our student, we had string school. So let's have string school here. Then now here is where we want to inherit. We want to inherit from our parent class. So this is where the constructor inherits. So we are going to have like our constructor is a student. Then now in here, you have to define the values that you are inheriting, but because they are already initialized, so you just have to pass them here. So you can just pass string. Actually, it's not a must that you define whether they are typed, because it is already defined up here. So you can just pass name, and then you can also pass age. But now, because this one is a property, a class property that is not initialized inside this constructor, so you have to say this dot school. Now you have initialized it. Then after that, you have to tell your constructor that I have certain properties that I'm inheriting from my superclass. So in that case, you have to use super like this. So then inside super, you pass the properties that you are inheriting. So you see, that's why I was talking about that super, super keyword. So I hope you see that now. So we have these properties here, then we initialize them. Then now inside, so actually this is where so inside our our student class, we have these two values that come from our parent class, two properties that come from our parent class, but they are already initialized. So we don't reinitialize them again. We just pass the values, but this one is not initialized. So we say this dot name. Then we tell our compiler that we have two values that come from the superclass. So super and then name. So I hope that is okay. So when you create an object of student, you need to pass in three values now, because the constructor that we are now using is the student constructor, because you see here we are calling the student constructor, but the student constructor is expecting three values. So the first value that we give is the name. So let's say David. Then the second value that we give is the age. So let's say 22. Then the second one that you give is the school name. So let's say this is the school that we give. Then so for now we've been creating just one object, but you can create multiple objects. You are not limited to the number of objects that you can create. So let's have like student. So let's say the student is Dalton. So let's do 24. Then maybe school is maybe that. So okay. So I hope you've understood the concept of inheritance of constructors, how these ones here work. Okay. So now we can have methods within these classes. So maybe void display person, just the name of the person. Then we can also print the age of the person. Then same to here. We can have a method for displaying student. Then just print person of the student now, because we've inherited. Now we have access to all that. Then also you can do age. So do the school, because now we have access to all that. So that's okay. So let's call student dot, then display student. So now we are calling the methods inside here. Then student2, student1 dot display student. So let's run that and see. You see now, let me expand that. So maybe I can use a separator so that we see. Let's use you can print something empty. So let's just print a new line, because print automatically infers a new line. So if you run that, so that we can separate. So you see now they are separated. So we have the first object named David age school, and then the second Dalton, like that. So I think that should be it for inheritance. I hope there is nothing I'm leaving out. Yeah, so let's see, after inheritance, what was our next topic? So our next topic was polymorphism. Our next topic was polymorphism. Okay, cool. So I hope you will just go through everything, classes, objects, and all that, and then now come to polymorphism. So polymorphism just means having many forms. So it consists of two words. Poly means many, and then morph means form. So having many forms, just like that. But now we have to do it in terms of code. So let's just clear everything here, and then I'll try to explain it in terms of code. So maybe we have a class, maybe person, or we define a class. So that's person. Then we can just have the normal. Okay, I like starting over so that you people can grasp these concepts as we proceed. So don't be asking yourself, why does it keep on clearing this? So I'm doing that so that every time, because how you learn to code is by like writing that code repeatedly. So I hope you don't mind that. Then the dot age. Then we'll just have also a simple method here, just like the one that we had. So display person. Then let's keep it simple. Just print name, print print age, just like that. Okay. Then we'll also have class. So it is the same class that we had, only that I'm trying to explain a different concept, which is called polymorphism. So we'll have it here. So also, when you'll be practicing this, just try to rewrite those codes as much as possible, because that's how you learn. That's how you understand how to code, because we had talked about super, so not really going much into details, just rewriting it. Then now we want to have a method with the same name. This like that. So having done that, now I want to explain the concepts of polymorphism. So we said that polymorphism is having many forms, but in terms of programming, or in that, polymorphism is just having the same method with different things. Yes. So it is having the same methods do different things, but you need to bundle it with the inheritance. So you need to do it together with the inheritance, because the only way that you will inherit these elements here is by using inheritance. So polymorphism, you see here we have this method called display person, and this method here called display person. So we want we want to use the same methods, the same method, but we want it to do different things. Okay. So here, so how you achieve that is by overriding. So it is something called uh, method overriding. So it is called method overriding. So that's how we achieve it. So method overriding is it is like a technique in which you can create a method in the child class that has the same name as the method in the parent class. I hope you get that. So the method in the child class overrides the one in the parent class. So here is the method in the parent class. Then we have here the method in the child class. So we want to override the implementation of the method in the parent class. So how we do that is here, you just use the override keyword. So you just use the override keyword. So here you just write, use that decorator, then you say override. So by that, because you will be telling your compiler that I want to change the implementation of the method display person. So instead of it just reading display person, I want it to read something else. So what is going to read? Now it is going to read name, then age, then now because we've added a certain property source, school. You see now we've changed the implementation, although we are still using the same name, but we have changed what the body does. So the importance of this is maybe you have a you have a certain function in your parent class that just does the general, it just does a general task. But now when you come to your child class, you want that function to do a specific task that is also related to this the first method in your parent class. So how you achieve polymorphism is just by using the keyword override. So overriding a method means you want to change the implementation of this method within the child class, but now you are overriding the first method within the parent class. So when we create an object here, so let's create an object. So age in name, that's it. And just have our default values that we had here at first. So student dot, okay, so it should be the student object. So student dot. So now we want to display. So let's call it a name that makes sense. So let's just call it maybe show, just the same way we used the other one. So let's do show here. Let's do show. So you see now it says this one is not defined. So let's do show so that it doesn't really look so bad. So our method is now called show. So student dot show. So see now there is only one method here. Like there is no two. Like in the other cases we used to have two. So student dot show. So this one will now implement some parts of this function, but now we are changing it. So let's run that. And now we have that output there. So you need to understand method overriding. So what method overriding does is that it overrides the implementation of the method in the parent class. So where it overrides it in the child class. So advantages of polymorphism is that a subclass can override the behavior of the parent class. Then it also allows us to write code that is more flexible and reusable. So assuming we had our parent class here, our method within the parent class had like a chunk of functions, a chunk of codes that implements a lot of things, but we only want to change a specific part of that code, not the entire code. So we just want to change a specific part of that code to do a different thing. So you don't have to rewrite that function from scratch. So you just have to change very specific parts within that code so that you don't do so that you don't make errors. Sorry about that. So that summarizes it for, for polymorphism. So we had, so far we've done classes, objects, constructors, encapsulation, inheritance. So the next method, that is the next concept for OOP that is remaining is abstraction. So the next one that is remaining is abstraction. So I think we should just jump right into abstraction. I'm just trying to to check where I did it. Okay. So let's go to abstraction now. So an abstract class is a class that cannot be instantiated directly. You see, in these other methods, in these other classes, we could create objects out of them. You see, this one we created an object directly, but for an abstract class, you can't create an object from it directly. What the main aim of an abstract class is that it just gives you a blueprint for creating other classes. Like it gives you maybe boilerplate code so that you can create other classes. But I'm going to, so an abstract class can't create an object directly. You need to use another class to create that object from it. But I'm going to explain that in code. So I know some people like it being defined. So an abstract class is a class that cannot be instantiated directly. Cannot be instance. So the spelling is there. Cannot be instantiated directly to mean you can't create an object. Can't create an object from it. So that's what an abstract class is. So how we define an abstract class? You just use the keyword abstract. So abstract class, then you can give it a name. So abstract class, then in this case, let's just stick with whatever we've been using. So abstract class person. So an abstract class, it normally has methods uh, that are that lack their body. The method lack their implementation because remember when we were creating methods within our classes, we had like, let's say, for example, display. So it would have their body like this, where we would say print hello world. So this is like this is like a concrete method. So this is a method that executes a certain operation. Okay. So that is a method that executes a certain operation. We call it a concrete method. But in abstract classes, it gives us methods with no implementation. So we just have this. So void display. So why this is important? Because if you remember the concept of polymorphism, so uh, when we go to a child class, now we will override this method and then give it its body. So that's why we are saying an abstract class is like a blueprint also for creating other classes. But an abstract class can also have concrete methods. So also here, so it can also have concrete methods. So let's say we have string name, then teacher, age. Then we just have our normal constructor. So person, this is that name, this is that age. What does it say? Okay, so I should use this dot age. So this is now This is what we call an abstract method because it doesn't have its body, so abstract method. Then now we can give it a concrete method now, so like a complete method. So maybe you can say void display info now. So because it is a concrete method, so we have to do something within the body. So maybe we can print name. Name. We can print the age now. So I'm going to demonstrate why we need this abstract method here. So so we can have like a child class. So let's have a student which inherits from class person like that. So we can also have our student constructor. So maybe let's have a string. So these concepts, like they are piling from where we started. So you need to understand first how classes are created, then you go to object, then after object, you go to other concepts like inheritance. It's like a kind of a procedure. So there's a flow in it that you need to understand before you can work on everything. So let's have also over there. So now let's see. Okay. So now if you hover, you see now we've inherited the class the class person. And now here we are getting the error missing concrete implementation of abstract class person dot display. So that is because uh, this the abstract class gave us the ability to now modify this method here. So when you come here now, you need to now complete that method. So how you do it is you use the override keyword, I think. Yeah, you should use the override keyword. So what you say is override because we are trying to override that method. So override. Then the method that you're going to override is display because we had display with no concrete implementation. So override display. Then now, so you see now because we are defining it, because we want to give it a concrete implementation, now the error goes away. So inside display now we can give our custom, now we can give our custom value. So now we can give our custom implementation of of the display function. So I think now of the display method. So I think now you get the concept of abstract class. So our abstract class here gave us this function with no body. It didn't have any body. But now when we create a child class, we are overriding the the parent display method here, and now we want to give it a certain real value. So in it we can have name. So yeah. Then we can also have age like this. Then we can also have school. School there, like that. That. So that is what we call, that is like, that is abstraction now. That is abstraction. Because here, this method didn't have any concrete implementation, but now we are now implementing it. So I hope you understand how that works. But now there's something when we will be creating methods, when we'll be creating a method, you really you need to understand how abstract classes work. So let's go and create, not methods, I mean objects. So void main, in our main function, let's create an object. So first, we can create an object of the student class. Then we can also create an object of the person class. So you need to understand that. So let's first create an object of the student class. So student is equals to student. So name, let's just do David. Then age, let's start like that. So now we've created an object of the student class. So then also let's create an object with a type person. So person. So should we just call it person? Let's just call it student2. Student1 is equals to, but it is working with the student constructor. So let's do that one. Let's do. So now I want to explain the difference between these two objects. The difference between these two objects. Because I think if you understand the difference between those two objects, then you will be mostly done with encapsulation. So here, one, so this gives me access to the concrete methods in the parent abstract class. Okay, that's right. So we have a student class. Yeah. So what we are doing here, you see, our type is of student, but remember, student was also inheriting from our parent class. But this one will only give me access to the concrete methods in this student class. Okay, so here we say gives access concrete in, it gives me access to concrete methods in parent child. So now I will be having access to the concrete method. So you see, this one is a concrete method because it is inheriting from this class. So I'll have access to this concrete method, but I won't have access to this. Okay. And also it gives me access to, it also gives me access to all the concrete methods within my class here. So you see, I have a method that is overridden here, but I can also have a method that is just within my class, so that is not even overridden. So I can just have display info. So this is just a method that stands alone. It doesn't depend on the abstract class. So I say does not limit. So so if I use this student, the type student, it gives me access to basically everything inside this class here. So it gives me access to every method that I can define here. But in my parent, I only have access to this. So I don't have access to this. So now calling our when we'll be using our method, so we can say student dot. So you see now I have access to display and also display info. So student dot also display info. So I also have access to display info. So I have those two methods there. Okay. So I hope you get that. When you use the type student, it gives you access to basically everything within this class and also the concrete methods within this main class, but you don't have access to this. So the next thing, sorry about that. The next thing, when you use, when now we use this person. So person one, it will give you access to the concrete methods in the parent class, but it only gives you access to the overridden method in the subclass. So now you'll only have, because we are trying to limit certain things. So if you use person type, so it will only give you access to this, but you won't have access to this. Okay. But in the parent, you will have access to this also. So let's define that. Gives access to concrete methods in parent, but only overridden methods in child. So now when you say student one dot, so you see now you should only have access to this overridden here. So let's try and see if we can get display info and we see if we get an error. So take note of that. Student one dot. So here we'll just use display because it is the overridden method. Then also here, you see we have display info up here. So okay, that's why there was some kind of confusion. So let me rename this function so that we don't get confused. So let's call this one display details so that we know what we mean. So display details. like this. Yeah. So now we said when you use student type, it only gives you access to the concrete methods in the parent class and also the concrete and overridden methods in the child class. So basically here it gives you everything. So let's try this student dot. So here you can, so we had details already. Okay, so here you can have the overridden methods and also the normal methods. So let's rename them so that I don't confuse you guys. So display details. So here maybe we can call it show. So I'm going to try to explain it again so that, because I almost got confused there myself. Sorry. So yeah, it should show. Yeah. Yeah. So I'm going to explain it again so that don't get confused. Sure. Okay, I did a poor work in naming my methods there. So here we have an abstract method called show. Then we have a concrete method called display info. Then in our child class, we are overriding the abstract method show, and then now we are giving it a body. Then we have a concrete method within our class here that is called display details. So I'm trying to differentiate the names so that we don't get confused. So now we are okay. So when we call a student, when we create a student object of this type student, now we have access to everything that is in this class. So that makes sense. So now we have access to everything that is in this class. So that's why we can call student.show. Then we can also call student.display details. Then also we have access to the concrete methods in the parent class. So we can also call student.display info. So let's call that. So student.display info. So we also have access to that. So that is what it gives you. So it gives you everything within the child class. Then also it gives you the concrete methods within the parent class. But here we kind of have a limitation in our person class. So the first thing that this one gives you, it will give you access to the concrete class implementation here in the parent class. So it will give you access to that. So let's do this. We have access to that. Then it will also give you access to the overridden methods here, but it won't give you access to this method. So let's do student one dot that. So you see that is okay. So if we try to access this method here, that is not overridden. So it is just a concrete implementation. So it will give us an error, I think. So student one dot that. So if you do that, you see there's an error. It says the method display isn't defined for the type person. So that one also gives you, like, it limits you on what you can access and what you can't access. So that is what we call abstraction. So guys, that marks the end of our class. So what you need to check on today are those concepts that I've highlighted. Know what a class is, know how to create the syntax of a class, and also know how to create an object. You can have multiple objects. know what instance properties and methods are, know the difference between static properties and static methods, know a default constructor, know what a constructor is, know parameterized constructors, then know constructor parameters. We have positional, we have optional, we have named and required parameters. Also, know the concept of encapsulation, understand private and public properties, understand getters and setters methods and properties, understand the concepts of inheritance. We have parent and child. Then understand how you use super keyword. Then also understand the concepts of inheritance and how it works using the extends keyword. Then also understand polymorphism, and lastly abstraction. So this is normally a gray area and most people don't usually understand it. So in our next session, we are going to be now working on real examples, because the examples that I gave here are just for demonstration. So thank you for tuning in and have a nice time ahead.